In this video, I'm going to go through 4 popular software options that we can use for data analysis using this example dataset from Dryad, and I'll put the link up in the video description. The software packages I'm going to use are Jamovi, which is free, SPSS, which is not free, but a lot of universities have a license for, and ours does. RStudio with R, which is a very popular option for statistics in a lot of disciplines, and then Python, because Python is a very popular programming language, and although I don't think it's the best for doing statistics, it can do probably what you want as long as you know what you're doing. And a lot of people do use it because it integrates with other parts of their workflow. So this is the data set. There is an Excel file, which I've already saved as a CSV and uploaded into different packages, but they can all open Excel files too, and a README file. So whenever data comes with a README file, you should definitely read it, as it will have information that you need about the data, particularly if some of the variables have codes attached and we need to know what they are so that we know how to interpret the numbers. Now, the steps that I'm going to go through, and I'm going to do this really quickly because the point of the video is more about showing how the different software options compare with each other rather than a tutorial in each of the software options. I want to keep it as fast as possible, and it will still probably take quite a long time. So I would like to open the data, show the variable information, put your level codes in. I should probably say descriptions for age and NAFLD, that's our non-alcoholic fatty liver disease. It's one of the main variables in the study was whether or not people had the non-alcoholic fatty liver disease. How can we quickly do a summary of NAFLD by age, a bar chart, a box plot, a histogram, and an independent t-test. So these are simple tasks, but they're very common tasks that we do a lot, and some packages may be better or worse at simple versus complex tasks. So it's difficult to show everything in one video, but this is what we're going to have a look at for this one. To begin with, I'm going to look at Jamovi. Now, I've already run all the analysis in each of these software options to make it faster, but I'll take you through the process and try and point out the positives and the negatives for each package. So for Jamovi, to open the data, we would just go open File Explorer and open it up like we would for any other piece of software. To look at our variables, we can see the name at the top, and there is also a variables tab, which allows us to put in a description. So this is very handy, and you can't necessarily do this with RStudio and Python. However, SPSS does allow you to put in longer descriptions. The difference between Jamovi and SPSS is that when you put a description in here, it's really just for you. The graphs will still show the, I haven't got body mass index, there it is. It'll still show the short label, the BMI, as opposed to the long label. Whereas if you do this in SPSS, it'll put this longer label on all your graphs and output, which is quite nice. Each variable has a type, and Jamovi and SPSS do this the same way. You can see the variable type by the little image up the top. So this has a ruler on it, so it's continuous. This is the symbol for ordinal, and this is the symbol for nominal. If we needed to change it, this is very fast. We can just use a drop down. This is under the setup tab, or you just double click on the variable. And most importantly, putting in the variable labels is very quick as well. Let me just quickly go to the README, and 0 is female. So female and male. And what I like about Jamovi is that you can see what the codes are. This is less obvious when you do it in R or Python. You can attach the words to the codes, but it's easy to actually get stuff in the wrong order or make a mistake and perhaps not realize that you've made a mistake, whereas this is quite obvious. Also in SPSS, it's quite obvious too. So they're very similar in that respect. So the next step might be to do a descriptive, get some descriptive statistics out. One of the things I like about Jamovi is that all of this analysis is linked to the data, which is different from every other package. So when you click on a bit of output, it shows you what you did to get it, and you can change it. So it will update as you go. Let me put age back in. So this is really, really convenient that you can get back to anything that you did and see all the options that you chose. Now, obviously, if you're running code, you can go back to your code and see what code you ran as well. The other thing is that this is dynamically linked. So let's say you had an outlier and you wanted to see how does the analysis change with and without the outlier. You can very quickly just delete it, see what happens, and then pop it back in again. Now, obviously, there's more sophisticated ways to do that, set some filters and some other stuff. But in terms of working quickly with data, if you're looking at a lot of examples, that's very convenient. So to get to the descriptives, if we were doing it from scratch, everything is in the exploration tab, and it's quite easy to put stuff into boxes and to tick off the charts that you want, which is quite handy. So we had some summary information, and then the next thing on my list was to be able to generate a plot. Now, the histograms and box plots I find very helpful. The bar plot here does not have a lot of options, so this is less helpful. And one of the things about Jamovi is that you can't really edit the graphs once you've made them. You can change the color palette, so there's some different themes that you could use. But the only way really to edit these graphs would be to export them as a scalable vector graphics format, SVG, and import them into something like Adobe Illustrator or I've forgotten the name of the cheaper version, Affinity Designer. That's the one that I've been using lately. So you would have to bring it into another package to change these fonts, which is a little frustrating. So it's quite fast to get things done, but you might not be able to get a final version of something that you need, depending on what level you need it for a report or a poster. This particular box plot, not box plot, bar chart, you can get more options by going through a different menu item. So if we go into the frequencies and look at contingency tables, you can see we have a lot more options here for doing the charts. And we can also do the chi-squared test and some other stuff while we're at it. So anything here, this is quite nice that you can see everything that you can do as you're doing it. So that is a bar chart. Next on my list, what was it? Box plot and histograms. So this is one of the reasons I like Jamovi, is that if I have a lot of variables and I want to see a lot of graphs all at once, I can just keep adding more into this variable list, and it will add more into the descriptives, and it will also generate all the graphs. So I can scroll through a lot of sort of exploratory analysis very quickly. This will depend a little bit on how big your data set is. So one of the downsides for Jamovi is that if you have a very large data set, thousands of observations, it's going to slow down a bit. And then I might use SPSS or something different. But this is quite nice for being able to quickly look at a lot of variables. There's also the density option, which I quite like. To me, this is a weird one because it kind of just smooths out the histogram, which is fine. The similar sort of equivalent on SPSS would be to generate a normal distribution based on the mean and the standard deviation of the data. And that's potentially more helpful to superimpose what a normal distribution would look like for that data. But I don't know, the density is nice too. So you could pick what you like there. I don't think there's any option here for doing that, but you could look at a QQ plot. So the last thing on my list is an independent t-test, and all of the tests have their own tab. So quickly, just to click on the t-test so you can see what that interface looks like. Very quick to do. You could do several variables at once. You have a grouping variable, and then you can tick off the options that you want. Now, in particular, I think it's very nice to be able to tick off some of these extra tests and to the thing I like the most is this plot here, which is quite tricky to do in R from memory the last time I tried to do it. This is the mean and the 95% confidence interval for each of the groups across this variable. And this is a really nice plot to be able to generate. So I find this quite helpful. SPSS will do this as well. So to me, Jamovi is the most similar to SPSS, even though it's built on R, except that it doesn't have the huge number of options that SPSS has. So SPSS will do a lot more than Jamovi, but it's also more complicated. But this is really good for a lot of things. The last thing to say briefly about Jamovi is that you can download extra packages for more advanced analysis. So the default Jamovi will have, I think, up the t-test ANOVA regression and frequencies, which is probably all you need for a first course in statistics. And then you can download extra packages. The linear model ones is quite comprehensive, so you can do a lot of stuff in here. Some of the multivariate stuff is not as well developed. And there is also RJ editor, which allows you to run R code from within Jamovi. So there have been a couple of times where I've run most of the analysis in Jamovi, and then I've had to do one little extra bit of script to get something else out that I wanted here. So you can run a little bit of code in here. I think you can only run code based on the default libraries in R. I'm not sure if you can load in extra packages. You might have to look that up or play around with that a bit. So that's Jamovi. When you save a Jamovi file, it will save all the output. So when I save this file and open it up again, it will have all of this output in it. And when I click on the output, I can see how I generated it. That's, to me, that's a positive. And that's different probably to all the other packages which don't save the output with the file. And you would have to rerun it to get it. I guess the only downside to that is if you just want to share the data and not all your output, you would have to probably export it as a CSV or something to clean up the data so you didn't have all your output in there. Okay, so that's Jamovi. Let's move on to SPSS, which I think is pretty similar. Obviously, SPSS came first. We're up to about version, I don't know, 30 or something. It's been around for a really long time. So the data view, very similar to what we've just seen. We have a little icon here to tell us what variable types we have. We can add in the codes for the data in the variable view. This is, again, quite simple. You can add on some extra codes if you want to and type in what you want the labels to be. The labels here for the variable, these will show up on graphs rather than the short label. So this is also quite handy in that you can set up what you want all your labels to be beforehand, and you can change your variable type. So to me, this is quite handy. And if there are a lot of labels and a lot of values for codes, and somebody else has already done all the setup in SPSS, this all gets saved with the .sav file. So if you open up somebody else's SPSS file, all this work has already been done for you and you can save it. So to me, that's a definite positive. Oh, I skipped opening up the data. So the opening up the data is just through file open, and you can open any data format. So when it comes to generating some analysis, this will appear in a separate window for SPSS, and this is a separate file. So you can save your data, which has all the information about it, as a SAV file, and your output would be saved as a separate document, and this is an SPV file. Or you can cut and paste everything into a Word document, and you actually get an outline here that you can edit to if you want to add notes and stuff to your output. So this is quite handy. So we'll have a look at a couple of bits of analysis, and this is where we can start to see that it's a little bit more complicated than Jamovi. So if we want to, probably one thing that I'll might do first that I couldn't do in Jamovi is that you can click on a variable and just quickly describe it. Now, this is really handy if you've got a big data set and you want to quickly get a sense of what's in each variable, and that you can get a very quick description and you don't have to do any other option. If we want to do a proper summary of a variable and split by another one, so I think we had a cross tabulation of age with NAFLD, there are a couple of ways we could generate that. So all the analysis is under the analyze, descriptives, and I think you can start to see here how many options there are in SPSS. That's why it can feel a little bit more overwhelming when you get started. We would probably do across tabs, put in our target variable. This used to be row and column, and I think I preferred that. But target list means if you were doing a table of participant characteristics, saying you had a whole bunch of variables you wanted to compare across two groups, you would put the target list in here, and then you would put your comparison group in the columns. So we could put our age categories in there and our NAFLD in the columns, and then we have a bunch of other options that we can check off for what we want here. So that's one way that you can get a summary out. If you want to save all the code for what you've done, you click the paste option, and that will tell you what the code is to do that. So SPSS you can do through syntax, or you can do through the menu options. Usually if I'm working with SPSS, I'll just use the menu options, but I'll probably, once I've got my analysis finalized, especially if it's quite a complicated analysis or a complicated table, I'll save the script for it so that I can redo it if I need to, or if I need to tweak it, I can. The other option for doing summaries is through the tables option. This takes a little bit longer to get the hang of, but it's also really handy, especially if you have a lot of variables and you want to keep popping them in. It's not so great if you want to mix variable types, but that's pretty much the same across all packages. So if I was doing this, I would do all my categorical variables together, and then I might do all my continuous variables together. Maybe if you're an expert user, you can mix and match them on the same table, but to me, it just gets a little bit messy and it's simpler to do it this way. Again, you can paste the code, or you can click OK to run it. Once you've got some code, you just select it, hit play, and it will run. So that was the table I just generated there. Okay, so that is some summary statistics charts. All the graphs in SPSS are under the graphs. There are a lot of sort of legacy options. Most of the stuff you want to do is probably in Chart Builder. To me, this is quite nice. It probably takes a little bit of getting used to, but basically you need to choose the chart that you want first. So if I wanted my stacked bar chart, I could put that in there, age categories, and non-alcoholic fatty liver disease. And then I can decide if I want counts or percentages, and how I want the percentages calculated. And once you get the hang of this, that's okay. The nice thing about graphs in SPSS is that they are 100% editable. So if you want to change the formatting of this graph, we can double click it and we can change the colors. That's a really interesting choice that I would probably never use in practice, but well, let's change another color too. Oh, this is not going to be good. That's quite ugly. I have to change it back. I can't look at it. No, that's a different one. Anyway, so we've got a burnt orange theme, and we could change some font sizes. So usually it's the font sizes you need to change, especially if they're for a poster. So let's bump them up a bit. Or we could change the whole chart size down a little bit if we want it to fit in a particular space. And then you can export this image in a variety of formats. So you could export this in a vector format or just as a PNG. So to me, SPSS is very convenient for graphs just because you can sort of edit the graph as you go, trying to get a sense of what looks good, and I quite like that. Some of the options in graphs take a little bit of getting used to. So if we wanted a histogram split into groups, there is a stacked histogram, which I personally don't like very much. Why did I drop that in there? But we can actually split this into rows by using some of these other options. So if I put that there and tick off we want a rows panel, you can see I can get my groups that way. So there's a lot of options in SPSS that take a bit of getting used to, but then once you are used to them, I think they're very convenient, and you can get what you want out of it in any sort of shape or size. The last thing on the list is an independent t-test. So all the analysis, and you'll notice that when I'm using these menu options, I'm accessing them both from the SPV output document and also from the actual data file. So either one will work. The only time you've got to be careful is if you have several data files open at the same time and you use the menus from the output document, it might choose a different data set to work with. It probably will choose the last one that you had in this output file. So you just have to be very careful if you're working with a lot of different data files at the same time. So analyze, what are we doing? Compare means, independent samples, t-test. So everything's here. You've just got a lot more options to wade through. And then when you run a test, you probably have a few more options to look at as well. In particular with the grouping variable, I think it's the NF, that fatty liver disease had the 0 and 1 codes. This is actually quite handy. If you had a third group that you wanted to exclude, you wouldn't have to do any filtering. You could just pick the 2 groups you wanted to do the test on there. And then SPSS will automatically give you a test of variances and give you 2 versions of the t-test. So obviously it depends what kind of analysis you want to do, but for most of the analysis options, there will be a whole bunch of tick boxes where you can choose exactly what you want. So you'll see that there's a whole lot of options here and how we on what output we want and what we want to see. Some people don't like this because it's a lot. I personally do, because sometimes you forget what's available, or you want to see a lot of stuff very quickly, or you're learning a new technique and you don't know what you don't know. But when you can see all the options, I personally find that quite helpful. And then if you want to save this, just make sure you save your SPV file separately and save your actual data file, 2 separate files. Okay, moving on very quickly. It feels like I'm going fast, but the video is already over 20 minutes, so perhaps not that fast. Let's look at RStudio. So this is, the language is R and the environment is RStudio, and you have to download both if you want to run it. This is, as far as I know, a dedicated statistics language, and I think it was based off, there was a really old program called S and S Plus in the 90s. I don't know if that's still around, but I think R is like the free version of S Plus. So this is code-based, and you need to write code for everything you want to do. Now, that used to be like quite a stumbling block, but these days with Copilot and other generative AI, you can get code generated quite quickly. Whether or not it works is another matter. Sometimes it's very good, and sometimes it'll lead you down a wrong path and make you do something very complicated. And you might have to say, are you sure that's what I should do? And then it'll say, oh, no, maybe you should try this. So definitely have some website tutorials open as well as Copilot if you're going to start learning code for this. Usually the biggest problem people have when they get started with R is that they forget to set their working directory. So set working directory to your source file, and then when you run like a line of code to read in your data, that's this one here, then it knows where to look for it because you've already set your working directory. The other thing that we need to do is load in the libraries that we want to use. So here, we actually don't need the read Excel because I had it as a CSV file, but if you had Excel, you need Excel. Summary tools and ggplot2. which is used for a lot of graphs in R. So we have to load in our libraries, and then we have to write some code. Anything with a hash is a comment, and I like to do nice big fat comments to divide up my code so I can see what's going on. And then anything we want to do, we have to write the code for it. Once we have loaded in our data, if we want to see it, we can say view the data and it will pop up in another tab. And we can see the information for the data here. If we want to add labels to our codes for categorical variables, then we need to write a line of code to do that. And I think it's quite easy to make a mistake by putting your labels in the wrong order. So you really need to be careful that you're doing things the right way. And then you can see them pop up over here on the other side as well. So you kind of have to do a bit more double checking that things are doing what you think they're doing. There's lots of different options for summarizing variables in different table formats, so you definitely can get nicer output. This code will just generate output in the console window, so you can see this is a summary of age, NAFLD, and I've got the counts and the percentages. If I wanted to customize that in any way, then I would need to customize the code or perhaps use a different package. So this bit of code here is saying we're using the summary tools package, and this is the command, and we could potentially use a different package for a nicer table. ggplot is quite popular. It does a lot of nice graphs, and you can modify absolutely anything. So from my point of view, it's not as easy as SPSS because you can't just sort of double click on what you want to change, but you can still do it. So you just have to search what's the code for changing the point size or the font size or the color, and you'll find some code on the internet or through AI to do that, I'm sure. The plots will show up in another screen, and then you can export them or cut and paste them into another document. You can use Markdown documents to write your report with everything embedded. I actually don't do that so much. I guess that's your personal preference, but usually when I'm communicating with people, they want to see stuff in either Excel files or Word documents, just because that's what most people communicate with. You can export a Markdown into a Word document, but people are more likely to export it as a PDF. And occasionally people send Markdown documents to each other without any instructions of how to view it, which is probably frustrating if you're not used to them. So there's more fiddling around if you're doing stuff with code. It's definitely not as fast, especially if you've got a lot of things to look at. But, you know, these graphs look nice. So that's a plus. I quite like these overlapping histograms with the transparency. I think that's quite nice. Okay, and then the last thing was running the t-test. And again, you don't get any checkboxes to pick what do I need, what do I want to look at. You have to know what you want to do and then look up the line of code to do it. So we can look up how to run a test of variances, then look up how to run a t-test. And there are some alternative libraries, I think, that can do this with better formatting, but the default formatting is really pretty ugly. So that is RStudio. And lastly, we will do a really quick tour through Python. Now, I've got Python open in VS Code, but you could use a different development environment. So again, we have a language, which is Python, and then we have the environment we're looking at it in. The difference here between Python and RStudio is that people pretty much always run R through RStudio, although I guess theoretically you could use something else. Whereas in Python, people use all sorts of editors. So if you're watching videos and looking for help, things will just probably look a little bit different depending on how someone has set up their workspace and what development environment they're using. VS Code has the Copilot built in. So if you're trying to generate code, you can ask Copilot as you go. And we will look at some tips and tricks for using AI for generating code in one of the workshops. So similar to R, we need to import our libraries. I also had a little thing in here to say I'm starting the script because, I don't know, something was happening. I couldn't tell if it was running, so I put that in there. We need to read in our data file. We can view the head of the data file. You can see stuff is appearing down here. Again, you can import other libraries which do stuff in a prettier way. I don't know if this is a strength or a weakness for the R and Python, the fact that there's often a lot of different ways to do the same thing, and it can take a little while to find out which one works best for you. If you ask Copilot what to do, it's just going to pick something at random. It's not necessarily the best option. So it's worthwhile getting familiar with the different libraries, Pandas, Matplotlib, SciPy, and just becoming a little bit familiar with them so you know what works for you and what doesn't work for you. So again, we have to make sure our categorical variables are being treated as categorical. There's no sort of viewer that gives you the little hints with the little symbols to say how it's treating variables, and we'd have to write some code if we want to assign some labels to our variables here. Summarizing variables can be a little bit fiddly, I think. There's probably some other packages that can do it as well. Occasionally stuff in Python looks more like it's been ported over from Excel, and then sometimes it looks like it's been ported over from R, and then maybe sometimes as a completely fresh code base. But pivot table, that's language of Excel. They do pivot tables. In statistics, we'd more likely call this a cross tabulation or a contingency table. So you could, again, there's probably other packages. I'm not an expert in Python because I don't really like it, but you can probably find a way to do what you want, the way you want to do it. And anything that you want to do with the plots, again, you can customize the plots through the code. So if I bring up the plot viewer, that was just the default settings. And then if I wanted to change the colors, I can't do it by clicking on the graph, but I can edit the code to add in the colors that I want. And this will depend on how you're running your Python, but when I was doing it this way, it wouldn't show me the next graph until I finished with that graph. So I found that a little bit odd. That's either a VS Code thing or it has to do with how I'm running this script. But the graphs are quite nice and you can customize them. So that's a couple of graphs. And then finally a test. This is very similar to RStudio, where we have to say what we want to do for each part of it. We don't have just tick boxes. The frustrating thing is it's not really written by statisticians. It's a little bit weird the way it works. A lot of the data setup for Python is different from any other stats package, the way it handles things, especially in repeated measures. I find it a little bit weird. So as long as you're prepared to look into how Python wants to set things up and how that's similar or different to other stats packages, you'll probably be okay. But I think you really need to know what you want to do first before you try and get the code to do it. And again, the code, the output is not that pretty. I don't know if I've run that. Almost scared to run it live in case it doesn't work, but it should work. It'll just appear down here. Probably won't be very pretty unless you download another package that specifically has pretty output, but it will do what you want eventually. So that's my personal view on all the different options. I think Jamovi is the best for getting started. If you want to see all the possible options for everything, then SPSS I think is really handy. R will do anything that you want. You just have to find the libraries and the code to do it. And Python will probably do what you want. It just will do it in a very weird way, according to me.